Hello everyone. So today in this runtime foliage generation system, we are going to implement foliage pooling into our in C++. So we already had implemented it with blueprints. So what I mean by foliage pooling is here. Let me speed up the movement so that we can easily test. So as the character goes further away, you see here in red you can see instances of foliage. So as we go further away, the ground tiles are removed and we add them in front of us as we go closer to maintain an illusion of infinite terrain. So like this, here I have reduced the distance of disappearing and appearing so that we can easily observe this. So here you see the trees are still there, so I'm not either removing them or reusing them in front of me. So we already had that function in blueprints, but since now I have converted that into C++ level for better performance, that part is broken now, and I'm going to restore that and I'm going to rewrite foliage pooling, that's what I call it, in C++ today. So we will have even more better performance. Okay, so before we get started, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel in the Patron page. So to the date there are over 1700 videos, and for each video you can access the project files once you become a member without a limit. So feel free to check it out. That would really help me to continue what I do in my channel. And back to the tutorial. So one thing, to speed up testing, here I have set this when I press num1, the speed of the game increases, so it's easier for me to test. So that's what I was using here. So if I press, this is the regular speed. If I press 1, you see game is faster. And you can see even the cloud movement is also faster. So because I'm just increasing this global time dilation, and with flip-flop, if I press the same key again, numpad 1, it will return to regular speed. That's just something extra. So here is the blueprint, and this is the C++ function we implemented yesterday. Which I have defined it here under U functions, add foliage instances. So we already have this remove foliage tile, which is a blueprint implementable event. So there what we do is we call this function when we remove a landscape tile. That should be here, remove foliage tile. And as I said, at the moment it's implemented in blueprint level. Here under foliage, remove foliage tile. So yeah, everything is in blueprint. So now I want to rewrite that in C++. So let me duplicate this and I'll call this remove foliage tile CPP because C++, and instead of blueprint implementable, I'll make it blueprint callable so that we can implement this function in C++ level. And we can I don't think we need to have a return value here, because even though I have a boolean return here, I haven't actually used that. So I'll make it void, and in place where I call this remove foliage tile blueprint function, let me comment that and call remove foliage tile C++ function and traceable mesh section. Okay, and we already know the logic that we have to implement because we already implemented it in blueprints. So here what we does is we get the index that we are removing, that we are going to remove from the terrain mesh. So mesh section index, and from the mesh section index we get the vertices and of the section relevant to this index, and from these vertices we get the first element and last elements, and using those elements we create a box. And then what we do is from these foliage components get the instance indexes that is within this box, and we mark them as ready to be relocated. So that means we add them into the pool. So next time when I have to add a new instance of one of these foliage types, we will just relocate them instead of adding a new instance. So the number of foliage instances will not blow up, so it will be better for performance. Okay, so first step is getting the vertices from procedural mesh and that means the terrain mesh, and get the first vertex and last vertex of that mesh section. So for that, let's go here, and there is the implementation. Okay, here. So first we need to access vertices, but in C++ we can use this terrain mesh. Let's say this get proc mesh section. This returns fproc mesh section data type. So index is type index, and we can put this in a fproc mesh section. No, actually no need to do that, because from this we can get vertex buffer, and this is from the type of fproc mesh vertex t-array. Okay, so fproc mesh vertex, and it's a t-array. T-array fproc mesh vertex. I'll call this vertices. Okay, that's an odd way to code, but in that way it's more clear what's happening, what I'm writing. If I just start directly for writing this part, you would not kind of understand, unless you are familiar with this API, you would not understand why did I first write that in first place there. At least that's what I was thinking. Okay, now we need to get the first element and last element. So f vector first vertex equals vertices from vertices dot, oh no, just the first element, so 0, and then position. Yeah, because this is fproc mesh vertex type, so from this we can access position. And f vector last vertex vertices. So how do we access the last one? We can get the count of vertices with num and -1, so that we can, this is the number of vertices, and number of vertices -1 is the last index, because indices starts from 0, basic stuff. Okay, now we have this first and last. I added the vertex as well to make it more clear. And the next step is creating this box. So here, f box. We have f box in C++. I just call it box equals f box. So we need to give this box min, box max. So basically we need to provide two f vectors. So f vector, f vector. This is what we need to provide. So now we can initialize f vector. First one, obviously, first vertex dot x and first vertex dot y, and then here what we do is get the mountain height and boulder height and multiply it with -1, so that this would be the lowest point that we may have in our level. That was the thinking behind that. So let's do the same. Mountain height plus boulder height multiplied by -1. That's the z. And here last vertex dot x, last vertex dot y, and z is this part without the -1 part, because this I want to be the highest point. Alright, now we have the box. Now the next step is this. For each foliage component, find out if we have already an element in this replaceable foliage map that has a set of instances which is ready to be replaced. If yes, we append the instances within this box into that array. So first let's get this instances array, and that is for each foliage component. So let's have a for array int foliage component index. A little long, but that's fine. And foliage components dot none. So we have all the foliage components references here. Now what we have in this foliage components is you instanced static mesh component component pointers. So you instanced static mesh component pointer foliage component. Let's get the relevant one for this iteration from the foliage components array. Index. Yeah, I zoomed in a little bit. Alright, now for foliage component, get instances overlapping box. So this returns JSON serializable array box. This returns JSON serializable array. Let's just try putting it to a T array. Should work. Int instances. Yeah, that's fine. Okay, now before we attempt to do replacing, let's just remove all the instances and see if this is working, see our calculations are correct. So for that, foliage component move instances. Alright, so this should remove. Oh, we got an error. Let's check the header file. Maybe I forgot to save after I changed this to void. Let's recompile again. Yeah, that was it. Okay, now if it works correctly, let's speed up. We should not see instances when one tile is removed. Yeah, see, no more instances are in there. Okay, one more thing, let me enable stat unit drop so we can see performance spikes when the replacing happens. Alright, now so far it's good, but we don't need to do that. What we need to do is add in these instances into replaceable foliage instances pool. So for that, this replaceable foliage pool. Well, actually we don't need to have this CPP part because we got rid of the variable that was in blueprint. So let's just refactor it. Alright, let's check the blueprint. Yeah, this was broken, but replaceable foliage pool. There should be a couple more places where we have that. All good. Yeah, everything is working still. Great. Now, so yeah, this is where we need to put the instances. So here, first let me show you how we do that in blueprint. Here, we check if we already have this, have a foliage data value relevant to this component key. If yes, we append, otherwise we just add it. So if we can replaceable foliage pool, fine, the key is foliage component. And now here this will return a foliage instance data. So foliage instance data. pointer for data. So if we don't have one, this will return a null pointer. So we need to make sure, if we are, before we try to append, if we need to make sure we have a valid pointer. So if for data, this will check for if it is null. If it is not null, if it is not null, we will go inside this if, and here we can simply for data instances append instances. This is actually much simpler than the way it looks in the blueprint, and we don't need to worry about this setting up references, updating members, etc., because C++ it is already dealing with pointers, so everything updates correctly. And if we don't have one, we can simply replaceable foliage pool add the key is foliage component, value is instances. Oh, sorry, this is not the way. F foliage instance data. Oh, hold on. No, key is, sorry, first part was correct. Instances we can't directly put. We have to put it like this: F foliage instances data, then instances, because this variable type is like this. Your instance is static mesh component pointer is the key, and F foliage instance data is the value. So I have to create one here. Okay, now the pooling part is done. What's next is using this when I spawn foliage. Instead of adding foliage, adding instance, I need to relocate one from the pool if we already have. So that means here, this is add new foliage instance. Before that, we can check relocate foliage instance from pool. Okay, so now to check if we have anything that is ready to relocate from the pool, we can do a find just like here. So we already have a reference to foliage component. It comes as foliage ISM component, so we need to use that. ISM, I put it there because it's an instance static mesh component. And if for data is not null, also this time we need to make sure we have valid elements for this for data. So for data instances now is larger than 0. That means we have elements or instances that are ready to be relocated. If this is 0, the number of instances 0, that means all the things were already relocated. Okay, if yes, foliage, we need to update instance transform rather than add in one like here. So foliage ISM component update instance transform. First we need to give the index, and that would be, here I use the last element of this replaceable pool. So I'll do the same here. Well, it would be easier. No, it's fine. So how do we get the last element? Data instances, again for data instances num -1. That's the index, and then we need to give the transform. So instance transform. We have already calculated that here in previous steps. And then we need to remove the last element from this instances array. So for data instances remove at again last index is this. Alright, and if I already update, there is no need for me to add another instance. So here we can add a continue, and before that we need to increment instance per step value. Okay, I think that's all. Let's see. Speed up. So here, let's go back. So you see, some of them are there, but most of them are not there. That means they are relocated to new tiles. So in time, those things will also be removed as we, see, as we keep adding more tiles. Okay. Have we not added any tiles? Yeah. Alright. They are going away. Okay, so the system is working, and let me go back to real time and see. As new tiles are added, pay attention here. See how is the performance. Maybe I'll do it in here. Yeah, see, new tiles were added, but we didn't see much of a spike, so frame rate is still good. It's almost 120. With everything going on, that's actually better. Yeah, great. Okay, so we can stop this episode right. And as for future plans, I want to add grass system, and also some way to spawn animals, and also they need to be relocated and reused as we move away from them, and as the tiles of the landscape are removed, we need to relocate the animals too, otherwise they will fall. So yeah, let's look into those things in future episodes. And thanks again for watching. As always, updated project files will be available for the download in Patron page. Link could be in the description below. And see you in another episode. Goodbye.